Have you ever looked out the window of an airplane and wondered why jet engines are almost always perfectly round? At first glance, it might seem like it's simply a design tradition or something that just looks aerodynamic. But if engineers had discovered a better shape, like a square, oval, or triangle, you can be sure they would have used it. The truth is, the circular shape isn't about appearance at all. It's the result of physics, engineering, and decades of trial and error. So why are jet engines round? Let's find out, right here, on History of Simple Things. The earliest practical jet engines appeared in the late 1930s, thanks to pioneering engineers like Frank Whittle in Britain and Hans von Ohain in Germany, who independently developed turbojet engines. These early engines already featured circular designs because they relied on rotating compressors and turbines. As jet technology evolved into today's highly efficient turbofan engines, engineers refined almost every part of the engine, but the basic round shape remained. That's because the underlying physics never changed. A spinning machine works best inside a circular casing. The most obvious reason jet engines are round is the enormous fan at the front. On modern airliners, that fan can measure over 11 feet, 3.4 meters across, and on some of the largest aircraft, it exceeds 13 feet, 4 meters. These blades spin at thousands of revolutions per minute, pulling huge amounts of air into the engine. Since the blades rotate around a central shaft, their tips naturally trace a perfect circle. A circular housing keeps the blade tips extremely close to the engine casing all the way around. This tiny clearance improves efficiency by preventing air from leaking around the blade tips. If the engine casing were square or another shape, there would be large gaps at the corners, allowing air to escape and dramatically reducing performance. A jet engine is essentially a machine designed to control airflow. Air enters the front, gets compressed, mixed with fuel, ignited, and finally expelled out the back to produce thrust. Throughout this process, engineers want the airflow to remain as smooth and uniform as possible. A round duct provides nearly identical conditions in every direction, helping the air move evenly around the engine's center line. Sharp corners, flat walls, or irregular shapes would create turbulence, pressure differences, and swirling air that reduce efficiency. In aviation, even a small loss in efficiency can translate into millions of dollars in additional fuel costs over an engine's lifetime. Inside a jet engine, the air pressure becomes incredibly high as it passes through multiple compressor stages. The engine casing must safely contain these forces while remaining as light as possible. Circular structures naturally distribute internal pressure evenly across their surface. This is the same reason scuba tanks, propane cylinders, and many pressure vessels are round instead of box-shaped. A square casing would concentrate stress at the corners, requiring much thicker, heavier materials to prevent cracking or failure. Every extra kilogram carried by an aircraft increases fuel consumption, so keeping the engine both strong and lightweight is a major engineering priority. The fan isn't the only spinning component. Behind it are multiple compressor stages, turbine stages, and a central shaft, all rotating at extremely high speeds. Some turbine sections spin at more than 10,000 revolutions per minute while operating in temperatures exceeding 2,000 degrees Fahrenheit, 1,100 degrees Celsius. These rotating parts must stay perfectly balanced. A circular engine keeps everything centered around one axis, reducing vibration and mechanical stress. An irregular housing would make balancing the internal components far more difficult, increasing wear and shortening the engine's lifespan. Although jet engines are incredibly complex, many of their parts are rotationally symmetrical. Compressor discs, turbine discs, shafts, seals, bearings, and many engine casings are manufactured using precision machining processes designed for round components. Building circular parts allows engineers to achieve extremely tight tolerances, often measured in fractions of a millimeter. Standardized round components also simplify inspection, maintenance, and replacement. If engines had complicated non-circular shapes, manufacturing costs would rise significantly while offering virtually no performance benefit. Could another shape ever work? Technically, engineers could build an engine with a differently shaped outer cover, and some military aircraft already use specially designed engine inlets that aren't perfectly circular to help reduce radar detection. However, once the air reaches the spinning fan and compressor, the engine quickly transitions back into a circular flow path. Researchers have explored alternative designs over the years, but none have matched the combination of efficiency, strength, weight savings, and reliability offered by a round engine. In other words, the circular core isn't just a convenient choice, it's the most practical one discovered so far. The next time you see a jet engine hanging beneath an airplane wing, remember that its shape is no accident. Its circular design allows massive fan blades to rotate efficiently, keeps airflow smooth, evenly distributes internal pressure, supports high-speed rotating components, and makes manufacturing more practical. Every curve has been refined through decades of engineering to maximize performance while minimizing weight and fuel consumption. Sometimes the best engineering solutions look surprisingly simple. A round jet engine may seem ordinary, but behind that familiar shape lies a remarkable combination of physics, materials, science, and precision engineering. It's one of those everyday designs that quietly proves nature often points engineers toward the most efficient answer. And in this case, that answer just happens to be a perfect circle. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.